College Algebra Exam 2 review. All right, so we are going to follow the instructions from the previous page, which talked about we're doing synthetic division, right? So right there it says use synthetic division to solve. Okay, cool. So that's what we're going to do. First, we need to reorder this one right here. So the highest one, degree that we see is 4. So we're going to say x to the 4th power. After that is a 3. Minus 6x to the 3rd power. After that is a square. So plus x to the 2nd power. And then after that's minus 6x. And then we can put, even plus 0 if we want to. We also can reorder this one as x plus 6. Okay, now we just need to bring down the coefficients, right? So we're going to put a 1 minus 6 plus 1. We don't need to put a plus there, though. Then we put in minus 6, and then we can put a 0 there. All right, here we go. Now, the number that we put there is going to be the opposite sign of that right there, so it's going to be a negative 6. Cool. So we bring down the 1. I've got to draw a little bit smaller. I'm going to run out of room if I keep going this way. So negative 6 times 1 is negative 6. Negative 6 plus negative 6 is negative 12. Negative 6 times negative 12 is a positive 72. 72 plus 1 is 73. Then negative 6 times 73 is negative 438. Negative 6 and negative 438 is negative 444. Negative 6 times negative 444 is positive 2,664. And 0 plus 2,664 is 2,664. We decrease the degree, so since we had a 4th degree there, this 1 right there is going to be to the 3rd degree, then minus 12 to the x to the 2nd degree, and plus 73 to x to the 1st degree. Clean that up a little bit. And then we have minus 444, and then plus, and this is going to be the remainder, 2,664 all over x plus 6. Cool. All right, so we're going to use the synthetic division remainder theorem and remainder theorem to find the value of the function. Okay, so basically what we can do is we can divide. We can do long division. I'll do synthetic division. We rewrite this polynomial right here, but just with the coefficients. So we have a 1 minus 7. We have a positive 5. We have a negative 6. And then right here, I'm actually going to divide by the 3 right there. So we bring down the 1, which gives us 1. 1 times 3 is 3. Negative 7 plus 3 is negative 4. Negative 4 times 3 is negative 12. Negative 12 plus 5 is negative 7. 3 times negative 7 is negative 21. Negative 21 and negative 6 is negative 27. Okay, and this should be the answer. Now I'm going to verify this though, right? So what I'm going to do is I'm actually going to figure out what happens if I plug a 3 into this equation. Okay, now theoretically, the answer should match that negative 27, which is the remainder. So let's see if that's the case. Okay, so we deal with the exponents first. 3 to the 3rd power is a 27. 3 to the 2nd power is 9. Then after exponents, we deal with multiplication. Negative 7 times 9 is negative 63. 5 times 3 is 15. Negative 6. And then we combine all that, we get a negative 27. Check. These match. Okay. So that's a use synthetic division and the remainder value theorem to find value of function. Probably mistyped that. Okay. Hopefully that makes sense, the way we do that. Okay. So we are going to list all possible rational zeros, and we're going to use synthetic division to test the possible rational zeros and find an actual zero. Use quotient form, this should be from part B, to find the remaining zeros. Okay, cool. All right, so first, let's find our P and our Q. So our P's are going to come from that 2, and the Q are going to come from this 2 right here, right? Oh, wait, sorry, we wrote that backwards. fix that. There we go. Okay. So, sorry about that. The p's are going to come from the constant, and the q's are going to come from the leading coefficient. There we go. Okay, cool. Now, what do we do straight? What is p equal to? Well, p is going to be equal to the numbers that you can multiply together to give 2, which is just 1 and 2, and they're both going to be plus and negative. Cool. Q is actually going to be the same because, you know, p and q in this case actually happen to be equal. That's why I got them backwards for a second there. Plus and minus 1 times plus and minus 2. There we go. That's p and q. Now we want to figure out what is p over q, right? Well, p over q is plus and minus 1 plus and minus 2 over plus and minus 1 plus and minus 2. And we're going to do all the different combinations of this, right? So plus and minus 1 over plus and minus 1 plus and minus 1 over plus and minus 2 plus and minus 2 over plus and minus 1 plus and minus 2. You don't have to write plus and minus twice, just plus and minus once is kind of good enough in this case. Over plus and minus 2. Okay, now we reduce. So we're going to end up with a plus and minus 1. We're going to end up with a plus and minus 1/2. We're going to end up with a plus and minus 2. And then 2 divided by 2 is just 1, so there's a repeat, so we don't need to do that again. So we know that all the combinations of p over q are these. Oops, sorry, p over q, so on and so forth. Okay, cool. So we figured it out. So find all possible rational zeros. Cool. I found all the possible rational zeros. That's what I got up to. Now I'm going to use synthetic division to test the possible rational zeros. Okay, cool. So what I'm going to do is I'm going to rewrite the original polynomial. So with just the coefficients, 2, 5, so negative 5, sorry, negative 5. Then it's going to be a positive 1, and then it's going to be a positive 2. I just rewrote the 2, understood negative 1, understood positive 1. I'm sorry, understood negative 5, understood positive 1, and a positive 2. Okay. All right, now we're going to divide it. I'm going to pick negative 1, which means I'm going to flip it to a positive 1 over here. So we'll just do the 1. There we go. Keep it simple. Okay. So I bring down the 2. And I say 2 times 1, or 1 times 2 is 2. Negative 5 plus 2 is negative 3. 1 times negative 3 is negative 3. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Cool. So I got it first try. All right. All right, now this is the quotient because we divided, right? Synthetic division, but it is division. So I'm going to rewrite this. So that's going to be 2x to the second power because we started with a 3, so it's 1 less. And then we're going to say minus 3x minus 2. Cool. And that's going to be multiplied by x minus 1, right? Okay, so we keep the x minus 1, and we're going to factor this, right? So we say 2 times negative 2. 2 times negative 2 is negative 4. We're looking for two numbers we can multiply together to give negative 4. Then if we add together, give you negative 3. That would be 1 and negative 4, right? Multiplying those together. Okay, so let's do that. So it's going to be x minus 4 and x plus 1, right? What we do is now I'm going to take this 2 right here, and I'm going to divide both of these by 2. Both of these divisible by 2. If it does simplify, we are going to keep it. Negative 4 divided by 2 is negative 2. And we have x plus 1 half. It does not divide evenly, so I bring it to the front, which is 2x plus 1. Okay. Use quotient from part B to find remaining zeros. Okay, so we got these two zeros. We're going to set these equal to 0. X minus 2 equal to 0, and 2x plus 1 equals 0. All right, so if I have x minus 2 equals 0, plus 2, cancel, cancel, x is equal to 2. And if I have 2x plus 1, plus 1 equals 0, it'll be minus 1, cancel, cancel, 2x is equal to negative 1 divided by 2, cancel, cancel, x is equal to negative 1/2. Okay, so we have a 0 here, we have a 0 here, and we have a 0 there. And I can kind of prove that, right? I rewrote it into the polynomial. I didn't really have to do that, but I just kind of want to prove a point. Oops, didn't need the parentheses either. So plus 1, cancel, cancel, x is equal to 1. Bam, right? But we already had it right here, so we didn't really have to rewrite that in the polynomial we didn't have to do all that if we didn't want to. Okay, so we use the quotient use quotient from part B to find the remaining zeros, and that's what we did. Cool. All right, so I want to find an nth degree polynomial function with real coefficients satisfying the given condition. Okay, so there's a generalized form of this, and basically most of it is just plugging it in and doing the math. So the generalized form of this would be something like, I'm trying to get myself enough room here, would be something like an is equal to x minus c1. They said 3, so I'm just going to have up to c3 here, minus c2, x minus c3. Okay, now I'm going to plug in what I know. I don't know the an. I need to solve for that. X minus, and now that's where we have a 4. X minus 4, x minus, and now they have the 2i. That's going to be both a 2i and a negative 2i. So first I'm going to do a negative 2i, and then I'm going to do a positive 2i. That's because this imaginary number part, that I part right there. Okay, cool. Now I'm going to simplify this a little bit before I plug anything in. So the x minus 4, I'm going to leave that, but I'm going to multiply this through. And it's the difference, right? So you're going to end up with the first term squared minus the second term squared. 2i times 2i is 4i squared. And then you're going to have to kind of fix that, because whenever you see an I squared, that flips the sign, right? So that's going to be x squared, not minus, but plus 4. So the I squared turns into a negative 1. Negative 1 times negative 4 is a positive 4. Kind of skipped a step there, but hopefully that makes sense. Okay. Now at this point, I've simplified it. Now what I can do is I'm going to move on to this part right here. So I made a polynomial function, but I need one that this is true. Whenever I plug in a negative 1, I get a negative 50. And that means I can solve for this, the unknown. So I'm going to plug in what I know, which is this negative 1. And I'm going to solve for what I don't know, which is this an thing, right? So I plug in the negative 1 minus 4. And then I have negative 1. Oh, I'm sorry, there's a square there. Squared plus 4. Okay, so I'm trying not to skip too many steps. Negative 1. And we keep the an. Negative 1 minus 4 is negative 5. A negative 1 squared is a 1. 1 plus 4 turns into a 5. So we have a negative 5 times positive 5, right? So times positive 5. Okay, so what that does is that gives me an is equal to a negative 25. Okay, now I should have written at this point right here, I should have written that this whole thing is equal to negative 50. The whole thing is equal to negative 50, whole thing is equal to negative 50, whole thing is equal to negative 50, right? So at this point right here, we're at f of negative 1, an negative 25 equals negative 50, and the way we solve for it is we divide by the negative 25. How do you undo the multiplication of an by negative 25? You divide by negative 25. And whatever you do to one side, you do to the other, which gives me an is equal to a positive 2. And now I get to rewrite the original equation after simplification, which is what I had right there. And but now I'm going to replace the an with the 2. So I say f(x) is equal to 2 instead of an, x minus 4, x squared plus 4. And that's how I came up with an equation, third degree equation, where all these are true.